I said, as we finished up last time, that I was going to emphasize theta does not have to be measured counterclockwise from the positive x-axis. You will measure theta wherever you can measure an angle, or wherever an angle is given to you. What do I mean by that? Here's where the rubber meets the road on this. If I tell you what I find is with if I ask a group of static students, day 2, day 1, and I say, well, what is the sine of theta? And they'll say, oh, it's y over r. No, it's not. I mean, it is. I get it. If this is true, IFF, and I don't know if you know what that means. For me, that means if and only if. Sine theta is y over r if and only if theta is measured counterclockwise from positive x. C number 1, right? C point number 1, back here. Theta does not have to be measured counterclockwise from positive x. So this is only true if this is true, and most of the time in the statics course, it is not going to be true. So be very careful applying this. I would strongly encourage you to not use this, because this is what always works. Sine theta is always opposite over hypotenuse. I am hoping they taught you SOHCAHTOA or something like that when you took a trig course or have learned trigonometry. This is always true. Always. Sine is always opposite over hypotenuse. Very rarely is it going to be y over r for us. Especially once we get past chapter 2 and 3. Very rarely is theta going to be measured counterclockwise from the positive x-axis. So you're welcome to use this, and you can still be in the habit of using this early in the semester, and then later in the semester, it is going to eat your lunch if you don't think about it this way. If you're still taking a calculus course or still taking a physics course and you need to think about it this way, that's fine. Just understand we're going to measure theta wherever it makes sense, because that's what we do as engineers. We're going to measure theta wherever I can get an angle. Most likely, I'm probably not measuring an angle. Most likely, I'm measuring the opposite side. I'm probably measuring the adjacent side, and I'm figuring the angle out from the tangent. But similarly, cosine theta is the adjacent side divided by the hypotenuse. Always. Again, if I ask a lot of times the first day or two of statics and I say, what's cosine theta? And people say it's x over r. No, it's not. No, it's not. Well, maybe it is. Maybe it is. It is always adjacent over hypotenuse. That is always true. It might be x over r, but it's probably not, honestly. If at any time you ask me about this whole thing, about, hey, why did you use the sign there for the x component? And I'm going to say, go back to lecture 1, part 3, and watch that. And that'll tell you why I'm using the cosine for y and the sine for x, because theta is not measured always from the counterclockwise of the positive x. Okay. I warned you. I was going to harp on this pretty hard. I just know from years of experience that I really need to try to be very aggressive about that early. And I get it. I know, because I've taught Physics 1 and I've substituted in a calculus course from time to time. And I know in those courses, my wife left me a message. Thanks, babe. Yeah, some of you guys have met my wife. That is hilarious. That is absolutely hilarious. Okay, where was I? Yes. So let's just continue on here, right? I was saying, I know in your calculus and your physics courses, you're probably going to they've really pounded that in your head, that sine is y over r. And here I'm telling you, try to pound it out of your head. It doesn't have to be y over r. It's always opposite over hypotenuse. Okay. For right triangles. So for right triangles, Ju, 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 ju. This is right. This is C, my hypotenuse, opposite of the right angle. Let's call this A over here. Let's call this B. I'm going to use theta here. I'm going to use phi down here. The sine of theta is always going to be the opposite side. So opposite of theta is A. So it's sine of theta is always going to be the length of the opposite side divided by the length of the hypotenuse. If I look at the phi angle, I could say that the cosine of phi, this is adjacent to phi. So cosine of phi is going to be adjacent over hypotenuse. This is adjacent to phi, and the c is the hypotenuse. Just like if I were to say the cosine of theta, well, adjacent to the theta is b. The hypotenuse is c. Cosine is adjacent over hypotenuse. And again, this would be the sine of phi because b is opposite of angle phi. Some other things to know here. Well, what we do know then is I could find a as from, if I know the hypotenuse, I could say c times the sine of theta. That's going to give me a. In this case, this would be the y component of this triangle, so to speak. If I'm saying b is the x and a is the y component, then the y component would be c sine theta. And then it would also be c cosine of phi. Right? So if I was given phi and I needed to know what is this y component here, well, given phi and the hypotenuse, I could find that a value. Same thing with b. B, of course, is going to be c times the cosine of theta. And it's going to be c times the sine of phi because b is opposite of angle phi. Also, some other relationships. Again, very simple crash course in basic trig. Going quickly because you should have seen this before. C squared plus a is equal to a squared plus b squared. Pythagorean theorem. And theta is equal to 90 degrees minus phi. So quite a bit of equations that you can use to navigate a right triangle. I'm going to pause, have a second, I'll be right back. Okay, I just want to throw in here also for any triangle. Doesn't have to be right. For any triangle, right? Meaning it's got a side up here at 90 degrees. But for any triangle, you have the law of sines. So some of the homework problems you'll find, especially if you look at solutions, they might use the law of sines, where they're going to say a over sine theta is equal to b over sine phi is going to equal c over sine, I'm going to say gamma, where gamma would be the angle opposite of c. I'll draw a triangle here in just a second. You also have the law of cosines. The law of cosines says that c is going to equal the square root of a squared plus b squared. And it's going to be minus 2 AB cosine gamma. And that's for any triangle. Angle gamma up here being opposite C, theta being opposite A, phi being opposite of B. So for any triangle, these work. Notice what happens if gamma is equal to 90 degrees, how these guys fall out. Right? So it also works for right triangles, but this is also more general. This works for any triangle. All right, so I'd be remiss if I didn't mention those things. Now, how often we'll use these? They're valid. You're perfectly acceptable to use this. This is L1. This is page 4 of something. Okay. What else do we need to do? Let's talk about the idea of similar triangles, because we'll use the idea of similar triangles throughout this course. So a common similar triangle that we will use is the 3, 4, 5 triangle. Why? Because they're pretty easy to construct. Meaning I could have a side of 4 and a side of 3. And if that's the case, then the hypotenuse has to be 5. How do I know that? Pythagorean theorem. You're welcome to try it on your own. This being the right angle. So that means if I measure this as theta, and I call this angle phi, so phi being opposite of the 4, theta being opposite of the 3, that means the sine of theta is going to be 3 over 5, opposite over hypotenuse, which is just simply 0.6. What is theta? I don't know. I can calculate it, but the truth is I don't care. We'll use 3, 4, 5 triangles a lot. I've taught statics many times. I don't know. I've taught statics many times. I don't know the value. And I don't care. It doesn't matter because it's not important. What's important is the sine of the angles is either 0.6 or the cosine of theta, which is going to be the sine of phi, is going to be 4/5 or 0.8. And the tan of theta is going to be opposite over adjacent. That's 3/4 or 0.75. Now, how is this helpful? Well, this is a similar triangle. So let's say I've got a triangle. Any scale of a 5, 4, 3 triangle will work here. So let's say I've got a triangle that is 20 by 15. Well, if I do Pythagorean theorem, I'll find that the hypotenuse is 25. Or I can also look at this and say, well, if this is 20 and I've got 20 and a 15 here, what I can do, sometimes you'll see that they'll draw this 4, 3 on that hypotenuse. And then what they're doing is they're telling you that this angle down here is this random theta angle that I told you I don't know what it is. And they're telling you this angle up here is the phi, right? And so they're saying, well, if I needed to know, for example, let's say I didn't know this 15. This was some unknown. We'll just call it y. How would I find this y? Well, if I know that I've got a 3, 4, 5 triangle here, I could say, well, that y is going to be, I could do it this way. I could say that the sine of theta is going to equal the opposite, that's the y, divided by 25. Right? And how do I do that? Well, I know sine theta is also 3 over 5, or 0.6. So y is going to equal 0.6 times 25. The sine of theta times 25 is going to be 15. Pause it there. I'm about at 15. I kind of like to keep these videos right around 15 minutes. So I'm about 15 minutes long on this. Take a look at this and see if that makes sense. Ask me some questions down in the comments there. But you will encounter this quite a bit, where you'll see some structure, maybe a cable attached between 2 points. Right? And they might put a triangle on this cable and say, well, this is a 4 and a 3. And they're telling you this is the geometry for it. All right, I'm going to stop there.